Okay, so today we are going to do the introduction to naming compounds or chemical names and formulas. And we're just going to go over the basics, so it shouldn't take long. After today, I want us to be able to list the differences between ionic and covalent bonded compounds, which should be easy. That was literally the last unit. And I want us to be able to identify polyatomic and monatomic ions. That's it. That's pretty easy. So a review of ionic compounds. They transfer electrons. So if you'll remember, we had, for example, potassium and nitrogen. Nitrogen has 5, actually that should go here, sorry. 5 valence electrons, potassium has 1. I'm doing this all wrong, but whatever. It's going to transfer that electron over to nitrogen. And that transfer is different than a covalent bond, because a covalent bond would be sharing electrons, when this one's actually transferring the electron over. So here you would have another potassium, and it would go here, and this electron would go here. So it would be for every 3 potassiums, you would have 1 nitrogen. And that's how ionic bonding would work. It's a transfer of electrons. It's usually, not usually, but it is made from a metal and a non-metal. So a metal somewhere from over here, non-metal from around here. And you'll notice the potassium is a metal, nitrogen is a non-metal. And the metals are the ones that are losing the electrons. They're the ones donating. And the chemical formula is arranged in the smallest whole number. So if somehow you did this and you got K6N3, then you would need to reduce it, because it needs to be in its smallest whole number ratio. And a formula unit would be this, K3N, instead of the K6N3, because the formula unit is just the smallest repeating pattern within that crystal. Remember those crystals? They form a very certain shape, and they repeat over and over again, and that smallest repeating pattern is this, the formula unit. So even though ionic compounds are made of ions, so this is a potassium ion with a +1 charge, and this is a nitrogen ion with a -3 charge, together, K3N, it would be neutral. Okay, so moving on to the main, I guess, topic of this unit, subunit, is that the ions can be monatomic or polyatomic. So up until now, we have dealt with ions that were monatomic, so just potassium or nitrogen, or basically anything on this periodic table. So that's monatomic, one. Mono means one. Poly, meaning more than one or many, would mean that there's more than one atom. It's made up of multiple atoms. So if you'll remember that group 1 has a +1 charge. Sorry, that's fatigue. Group 2 has a +2 charge. Group 13 has a +3 charge. Group 14 has a ± 4. This group, group 15, has a -3 charge, -2, -1 charge, and then that's neutral. So just keep that in mind as we are going through and combining these elements together, or ions. So monatomic cations is basically one atom, and cation is positive. So basically anything over here in the atom side. So a monatomic cation could be lithium. Lithium has a +1 charge. It could be magnesium, which has a +2 charge. These are both monatomic cations. Monatomic anions, anion just means ending. Oh, and by the way, I'm sorry, to name these, all you do is write the name, write its original name with the word ion at the end. So this would be lithium ion. This would be magnesium ion. Okay, so that's how you would name these. And so that's your monatomic cations. You name them by writing their name and the word ions afterwards, or ion, and you're good. Moving on to anions, so monatomic anions, that's all the nonmetals over here. Anions are the negative ones. These are negatively charged and single atoms. So how you would call these is you basically say the first part of their name, but change the ending to "ide." So instead of, for example, chlorine, it's chloride. So iodine has a -1 charge. Sulfur has a -2 charge. So how you would call that is iodide. Instead of iodine, it's iodide. That's how you would call it, this ion. And this ion would be called, instead of sulfur, it would be called sulfide. Okay, so that's all you do with the monatomic anions. You call them by their name. Just change the ending to "ide." Monatomic cations, you name them their actual name, but with ion at the end, and that's how you name them. Now with polyatomic ions, it's easier. With polyatomic ions, you're just naming it its name. So with this, I'm not really going to draw anything on here, so look at the PowerPoint. And if you'll notice that they're all here for you, and this will be given to you on every test from now on. You won't be expected to memorize this list. Last year I had the honor students memorize a certain few, which in IB it actually will be helpful for you. I'm still not sure if I'm going to make the honors memorize them. It was like 7 of them, but I think I'm not going to, because there's enough going on right now. And in IB though, they will just give you these. They'll actually give you the name and just expect you to know it. So I mean, if you want to front load any information, go ahead and memorize it, but you'll probably forget in the summer. I'm not big on memorization of just facts. Like, I'm never going to make you memorize the periodic table. I really shouldn't make you memorize polyatomic ions, but in IB they will make you memorize some of them. So but you'll deal with that if you do go to IB. Okay, so also just kind of some trends on this polyatomic ions list is that the only positive charged ion is ammonium. Okay, so the only positive charged ion is ammonium. All the rest are negative charge. So I put all of them in a group. So here's your -1 charge group, here's your -2 charge group, and here's your -3 charge group. And all of these groups, how you would call them is just by their name. So if you see this here, it's just carbonate. So for example, if you had, we'll just take potassium because I keep using it. Potassium has a +1 charge, and we'll look at carbonate, which is CO3 -2, okay? I will teach you this in like the next video, but you're gonna bring these charges down, and it'll be K2 CO3. Really what I'm trying to do is get you to know how to name them. So what you would call this is potassium carbonate. That's all its name would be. But that's for more of a later video. I'm just showing you a quick example instead of just flashing this polyatomic ion sheet up here and expect you to do something with it. Okay, so review of molecular compounds or covalently bonded compounds. So this is covalently bonded. All of your polyatomic ions are covalently bonded, which means that they are, so CO3 would have, they have those bonds. It's not like lines, they're not transferring electrons, they're actually sharing electrons here, which means they're pretty well bonded compared to like this would be. Okay. So anyways, as far as molecular compounds, they share electrons. So for example, let's just look at, let's look at carbon dioxide, so CO2, okay? They're bonds from 2 nonmetals, carbon and oxygen. They're on the nonmetal side of the periodic table, oxygen and carbon. I always like to put whatever atom that needs the most that needs the most bonds in the middle. So carbon has 4 valence electrons, and oxygen has 6. So you need 2 bonds for oxygen and 4 for carbon. So carbon will be in the middle. and we'll just go ahead and put oxygens on both sides. Oxygen has 6 valence electrons, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And the covalent bonding, we just had a test over this, so you should know it quite well. They're sharing electrons. We're not drawing a circle and saying it's the electrons going here, which is a common misconception with my students in the past. So don't think that oxygen's giving electrons, or no one's giving or transferring electrons, they're sharing. So the sharing creates a bond, and that's 1 and 2 bonds. So the molecule will have a double bond, and in IB they'll call it a pi bond, but here we'll just call it double bond. And that's what the molecule will look like. It'll be linear, and it'll be nonpolar. So this is a covalent bonded molecule. So just know that it is with nonmetals. They're sharing electrons, they're not transferring. This is the type of bond that polyatomic ions are. I think that's it. Yeah, that's it.